All right, so if we're considering this problem where neither a and b are odd, where a and b are both even, then we've got a couple of different ways to proceed. Although I'll only really talk about one. I mean, let me say way number one that I won't really talk about is that if you're clever, you can get away with by parts, which sometimes involves a lot more effort, but you can sometimes do it. Sometimes it's a reasonable thing to do. But on the other hand, the other strategy to use is to use these very nice identities that the sine squared is 1 minus the cosine of 2x over 2, and the cosine squared is 1 plus the cosine of 2x over 2. What these things let you do is they let you basically cut down a and b by a factor of 2 by just changing your angle. Let me just do it symbolically first, and then we'll kind of do it with some examples. So let's imagine that a and b are even. Well, actually, let me just kind of visibly make the exponents even by saying, let's suppose we have sine to 2a and cosine to 2b. I'm just doing it symbolically, but we'll do examples after. So what we would do is then say that this first thing is actually the sine squared of x to the power a, and the second thing is the cosine squared of x to the power b dx, and use these identities to get 1 minus the cosine of 2x over 2 to the a, and 1 plus the cosine 2x over 2 to the b. Now, dx. Now, what have we gained by doing this? I mean, we have a bigger expression, but if you think about it, the exponents all dropped by a factor of 2. So we have, in some sense, a simpler problem. Let's take a look at an example where we're integrating powers of trig functions where the exponents are both even. So if they're both odd, we have the strategy of moving all but one to the other so that we make a nice U-Substitution. Here we don't have that luxury, but what we're going to do is we're going to use these identities that the sine squared can be written as 1 minus cosine 2x over 2, and the cosine squared can be written as 1 plus cosine of 2x over 2. So as we said before, this strategy will let us write this as, so we'll write this as a sine squared squared, and we have a cosine squared dx. So plugging in these identities lets us write this as a 1 minus cosine of 2x over 2 squared times a 1 plus the cosine of 2x over 2. So this is nice. We've reduced the problem to just cosines, and there's only 3 things going on instead of 6, so that's better. But to really work with this, we actually need to multiply this all out. So let's just do it. Let's not delay. Let's just face it. We've got 1 minus cosine 2x over 2, 1 minus cosine of 2x over 2, and a 1 plus. It'll look a little simpler if I pull out all those 2's. Let me write this as I have a 1/8, 3 factors of 2, 1 minus the cosine of 2x, 1 minus the cosine of 2x, 1 plus the cosine of 2x. And it's easier to multiply it like this because these two here form a difference of squares. So it saves me a little bit of work. Multiplying these things through, I get a 1 minus cosine squared of 2x. And now I have to FOIL it. There's no help for it. I just FOIL it out. We eventually do have to do some work. And let's see what we get. So we have 1 times 1 is 1. 1 times the minus cosine squared, I'll get a minus cosine squared of 2x. How about this? I have a cosine, minus cosine 2x times 1. I get a minus cosine of 2x. And then we get a cosine 2x and cosine squared 2x. That gives me a plus cosine cubed of 2x dx. Okay. So now, what do we need to do? Well, we have 3 or 4 separate integrals to work with. So we have 1/8 of the integral of just 1 dx minus 1/8 the integral of cosine squared of 2x dx minus 1/8 the integral of the cosine of 2x dx plus 1/8 the integral of cosine cubed of 2x dx. Okay, let's get some more paper. So let me recopy what we have there. 1/8 the integral of 1 dx minus 1/8 the integral of cosine squared of 2x dx minus 1/8 the integral of cosine of 2x dx plus 1/8 the integral cosine cubed of 2x dx. Okay, we're going to look at each piece separately. So first off, the integral of 1 dx, that's equal to x plus c. I'll ignore the plus c's for the moment. Integral of the cosine squared, well, let's do the integral of the cosine of 2x, since that's easy. The integral of cosine of 2x, we'll just do the u equals 2x. du is 2 dx, but we all know how this goes. We're going to end up with 1/2, an antiderivative for the cosine will give me a sine. I'll end up with a 1/2 of the sine of 2x. No, plus c. It's hard for me to not write the plus c's. Okay. That's fine. Now, what about the integral of the cosine squared of 2x dx? Let's go do that on the board. Alright, so the cosine squared of 2x, for this one, all we really need to do is use that same kind of identity that changes cosine squared of something to 1 plus the cosine of twice that thing over 2. But we're going to apply it in the case where we have a 2x here. So y is 2x, and so 2 times 2x is going to give us 4x. So that gives us a way of rewriting cosine squared 2x in this way. So we can just rewrite this integral as 1 plus the cosine of 4x over 2 dx. That's just 1/2 the integral of 1 dx plus 1/2 the integral of the cosine of 4x dx. Okay, so of course this first one is just 1/2 of x, and the second one, 1/2 of, so we could do U-Substitution, u equals 4x, du is 4 dx, and if you carry that through, what we find is that there ends up being an extra factor of a fourth when you convert from the dx to the du. So we get 1/4, and then instead of a cosine, we have a sine. The integral of cosine is sine 4x plus c. And so that's that integral there. Alright, so now we have the cosine squared of 2x. The integral of that ends up being 1/2 x plus 1/8 of the sine of 4x plus c. Next will be the integral of cosine of cubed of 2x dx. Let's go ahead and work that out. For this one, cosine cubed of 2x, we're going to use the standard strategy of converting two of the cosines into sines. So that'll look like, let me just break this up as a cosine squared of 2x and a cosine of 2x. And this cosine squared, I'll change into a 1 minus sine squared of 2x, and then cosine of 2x dx. Alright, so now we're just really set for a U-Substitution. I'm going to make u to be the sine of 2x, because du is going to be pretty close to that cosine of 2x dx. It's actually going to be twice the cosine of 2x dx. So, so to actually get the expression I have there, cosine of 2x, that's going to be my half du. So all told, what I have right here is the integral of 1 minus u squared. And then cosine 2x dx is 1/2 du, so I have a factor of 1/2. I have my du. Now I go ahead and do the integral. So I got 1/2 of u minus 1/3 of du. That's 1/3 of u cubed. And now just substituting back in, where u is the sine of 2x, this just gives me, I have 1/2 of the sine of 2x minus, I have a 1/2 and a 1/3, gives me a 1/6, the sine cubed of 2x. And there we go. Alright, so now we have the cosine squared of 2x. The integral of that ends up being 1/2 x plus 1/8 of the sine of 4x plus c. Next will be the integral of cosine of cubed of 2x dx. Let's go ahead and work that out. For this one, cosine cubed of 2x, we're going to use the standard strategy of converting two of the cosines into sines. So that'll look like, let me just break this up as a cosine squared of 2x and a cosine of 2x. And this cosine squared, I'll change into a 1 minus sine squared of 2x, and then cosine of 2x dx. Alright, so now we're just really set for a U-Substitution. I'm going to make u to be the sine of 2x, because du is going to be pretty close to that cosine of 2x dx. It's actually going to be twice the cosine of 2x dx. So to actually get the expression I have there, cosine of 2x, so that's going to be my half du. So all told, what I have right here is the integral of 1 minus u squared. And then cosine 2x dx is 1/2 du, so I have a factor of 1/2. I have my du. Now I go ahead and do the integral. So I got 1/2 of u minus 1/3 of du. That's 1/3 of u cubed. And now just substituting back in, where u is the sine of 2x, this just gives me, I have 1/2 of the sine of 2x minus, I have a 1/2 and a 1/3, gives me a 1/6, the sine cubed of 2x. And there we go. Alright, so the integral of the cosine cubed, we got 1/2 of the sine of 2x minus 1/6 of the sine cubed of 2x. Okay, altogether, all these parts will be combined. The cosine of 2x, that was this piece, and this cosine squared will be that piece, and the cosine cubed will be that piece. All these things will combine to give us the final answer. So let's see what that actually is. So if you remember, where this all started was we were trying to figure out what's the integral of sine to the 4th x cosine squared x dx. What we ended up showing is that's 1/8 the integral of 1 dx minus 1/8 the integral of cosine squared of 2x dx minus 1/8 the integral of cosine of 2x dx plus 1/8 the integral cosine cubed of 2x dx. This first part is going to be just 1/8 of x. The second part I have a minus 1/8. The cosine squared of 2x gives me a 1/2 x plus 1/8 of the sine of 4x plus of just 4x. And then that's the cosine squared. Now this part I have 1/8 of the cosine of 2x. I got 1/2 the sine of 2x. And then 1/8 the cosine cubed. I get 1/8 the cosine cubed was a 1/2 sine of 2x minus 1/6 sine cubed of 2x plus c.